All right, today my goal is to get through the 2018 FRQs. We're here Monday. The following assignments will be due at the end of class on Friday. This Friday. 2019, 1 through 6 FRQs. You have the packet. It's the same packet you're in right now with the 2018. All right. Progress checks 3 and 4. Units 3 and 4. 4 videos from AP Classroom, and then apparently, was it this class you guys told me about the induction. It's going to affect this class on Wednesday, right? Okay. NHS inductions. So we're going to have to figure that out. I may make that like a take-home quiz. 7th period would benefit since they're going to have class that day. They're going to have extra time, but you guys just need to kind of plan accordingly. Again, my job is to do what you got, like to do what's necessary to get you guys ready for this test. All right. There's a lot at stake when it comes to college credit that I take seriously. I hope you guys know that. I'm not trying to pile on work, but I'm giving you what I think is necessary to get you to where you need to be, because we're not yet. We're not there yet. All right. Today, I think is a huge step in going over the FRQs and looking at them and saying, here's how you should approach these questions. Okay. So valuable. I want you guys, and this is kind of a weird statement, but this is the only way I think about it. I want you guys, as you read the FRQs or any question, I want you to like be thinking of them the way I have taught you to think of them. And so as we go over them, I want you to like read it and hear like me prompting you, say, oh yeah, when we read about this type of problem, this is the process we should be doing. Does that make any sense at all? Like, there should be that direct connection between reading it and taking it back in your mind to when we did it in class. All right. There's that comfort that comes from that, of remembering, oh yeah, we did that in this section. Here's what we always did. All right. I need to get the packet. Some of these FRQs, they like have the question at the top. Others, they just give the rubric. So let me grab a packet. 2018, number 1. People enter a line for an escalator at a rate modeled by the function r given by, and it's a piecewise graph, where r of t is measured in people per second. T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in the line at t equals 0. And I asked you this during that late start day. How many of you did that jump off the page at? Did you underline it in your packet? At t equals 0, there are 20 people in the line. Yes? How many of you? Okay, if you didn't, do it now. Underline it. Okay. There are 20 people in line at t equals 0. Here are the types of questions you should anticipate. Question 1. How many people have entered the line over a time interval? Does the t equals 0, people equal 20, does that affect the number of people that have entered the line over a certain time period? No. How many people have left the line? No. How many are in the line at t equals blank? Does that affect that one? Yeah, because there's 20 to start, plus however many have been accumulated or taken away, whatever. Okay. Second thing I need you to understand, and I think this is one of the ones that threw you off, was how many of you got thrown off because there were 2 different rate functions involved here? Be honest with me. I need to know how to explain it. Okay. So here's what I want you to get from this problem. And this is just the way my brain works. Whenever you're a kid, whatever, you took a bath, hopefully at some point you had the experience of turning on the water and opening the drain at the same time. Who did that? Come on, you know who you are. You had the water running and you also had the drain open. You know who you were. Okay, you're like that. You're an experimenter. You're like, oh, Drain's closed, turn on the water, yeah, the bathtub's going to fill up. Okay? Pull the plug. Is the water, they're both, so faucet's on, drain's open. Yes, it's wasteful, but it's all about experimentation in science, okay? Is the water level rising or falling? What question would you ask? It depends on the rates, right? If the rate entering is greater than the rate leaving, the water level is going to keep going up. If the rate leaving is greater than the rate entering, the water level is going to drop. Do you follow me? I want you to think of that example. They love to ask questions like this. Okay? So if you're asked, is the water level rising? Okay, maybe they didn't say that here. Are the number of people in line increasing or decreasing? Well, is the rate of people entering the line greater or less than the rate of people leaving the line? Right? Doesn't that seem logical? So kind of think of that in context. All right, A. How many people enter the line from 0 to 300? Simple integral 0 to 300 of just R of t, just the entering the line rate. Okay? Part B. During the interval from 0 to 300, there are always people in line for the escalator. How many people are in line? Okay, now we have to involve that 20 at t equals 300. Do you agree? Now, they combined it into one integral. Okay, ignore the 20 for a second. Do you agree the integral from 0 to 300 of r of t minus integral from 0 to 300 of 0.7, what would that give you? Ignore the 20. Well, 0 to 300 was the number that I've entered. 0 to 300 of 0.7 is the number of people that have left. What's that difference? What does that mean? Come on, this is your part. Isn't that number of people in the line? Sorry, I bailed you out. Sorry. Plus 20, that's how many there were to start. Okay? I guess I should say it's the net change in the number of people in the line. And then plus 20 is the total number of people in the line. Does that make sense? Okay. Part C, for t is greater than 300, what is the first time there are no people in line? How do we do on that one? All right. D, at what time is the number of people in line a minimum? All right. Make sure you consider endpoints there. You know, at 0, there were 20 people. At 300 seconds, there were 80 people. How many of you found the critical points? Got 3.803 and 158.070. How many of you got those two values as critical values? Nobody. Okay, take a look. Do you see how they figured that out? The first derivative test is all over this exam. Find the maximum, find the minimum. Okay. Do you remember back in chapter 4 when we did that first derivative test? Step 1, take the derivative. Step 2, set it equal to 0. Okay. Those are very robotic steps. I want you to go back, cycle back to it, and now understand the application of it. When we find the derivative and set it equal to 0, aren't we finding smooth peaks and smooth valleys? So find the derivative, set equal to 0. But wait a minute, we could have had a maximum at an endpoint, or a maximum at a right endpoint, or a minimum on one of those, right? You have to consider endpoints. Okay? Well, if I want to take the derivative and set it equal to 0, what am I finding the extrema of? At what time is the number of people in line a minimum? Well, shouldn't I take the derivative of the number of people in line function, set it equal to 0, and test? Where's my number of people in line function? Isn't it 20 plus the integral from 0 to t of r of x dx? Now, they use some dummy variables here. They got rid of the t here. You guys remember that? I mean, do you recognize 0 to t of r of x is the number of people entered? Minus 0.7 t, number of people that have left. Yes? What did they do there? I don't see an integral. I don't see an integral there. What did they do? They took the inside derivative, right? What's the inside derivative of negative 0.7? Negative 0.7 t. Do you see it? But that's the number of people. I need to take the derivative of this. What's the derivative of 20? 0. What's the derivative from 0 to t of r of x dx? Make me proud. R of t, very good. The derivative of an integral is the integrand with the top bound, right? R of t minus, what's the derivative of negative 0.7 t? Negative 0.7. Set it equal to 0. Well, r of t minus 0.7 equals 0. Well, that means r of t equals 0.7. Calculator, graph it, graph the r of t function, right? Set it equal to 0.7, or r of t minus 0.7 equals 0 if you want to look for zeros. And that's where you're going to get these values. Does that make sense? Guys, I know this is challenging. You have to start chipping away at some of these. You're going to see one like this again. Okay? So you should stop. You should think. If I see a problem like that again, what will I do differently? Okay? I was not planning this at all. Is it okay if I scroll through a couple years randomly? I have not planned this. I just want to show you. I want to prove a point, and I could be really embarrassed here. Okay? Which it's probably a good tactic on my part because now I have your attention. Ooh, he's going to embarrass himself. All right, let's pick a year. 2011 is considered modern test. Dom, would you close that for me? 2011 on. What do you guys want to pick? 2014, I heard first. Let's see. Free response. This could embarrass me. Let's vote yes or no. Is this a problem like the one we just did? It's got some rates, but I don't see it's not like necessarily rates like we're talking about, right? That's an area between two curves. That's more of an FTC problem. At time t equals 2, A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving the integral that gives the position of the train A in meters from the origin station. A second train B travels north. Find the rate, which the distance between A and B is changing at t equals 2. Similar. There's sometimes you're going to see problems that are like not exact, but similar. Okay, where you need to use integrals to find how far it is to the right or to the left of something. They like to do that, just some random question. Ooh, separable differential equation. All right, let's go to another year. So we found one similar. Madison, you were the second person to answer. What did you say? 16. So we have the 16 practice tests. Let's go to the actual FRQs from that year. Water going into a tank, water leaving a tank. You see it? Only they give us WT as a function. They give us R of T as a table. Let's take a quick look at this. How would you estimate R prime of T? Oh, wait, hold on a second. I want to make sure I emphasize this one point. What am I going to emphasize? Have you had a chance to read it? There are 50,000 liters at T equals 0. I would underline it, box it in, star it. All right. What's that going to affect? The total amount of water in the tank, right? Now, here's another pattern I've noticed. They're going to give you some softballs. Okay, they're going to give you some softball questions first. Don't go straight in your mind to I've got to use the 50,000. I've got to use the 50,000. Like it'll come, but typically not early on in the question. They're going to give you a couple softballs first. How would you find R prime of 2? Well, I don't see a 2 up there. Well, at 1, it's 1190. At 3, it's 950. A good approximation for that slope is to use the average, which is the sequence slope, right? F of B minus F of A over B minus A. That's part A. You use the left Riemann sum with 4 subintervals. Got it? Okay. Use your answer for part B to find an estimate of the total amount of water in the tank. Should I use the 50,000? Yes. Okay. There you go. There's no one just like it. One more. 2012? Good try. Kind of. At T equals 0, the temperature of the water is 55 degrees. See a pattern here? Okay. I think this is valuable. All right. I want to do more of this as we kind of walk in through. Just bird's eye view, look down at the problem, say, okay, this is this type of problem. This is what we should expect to see. Look at the first question, W prime of 12. Well, I don't see a 12 up there. It's okay, right? Look, same thing. That minus that over that minus that. We'll give you an approximation at 12. Do you see how you can start to chip away at points here? Okay. All right. Good enough. Now, just to kind of run through it real quick. Area, FTC, and I haven't looked. It's just they always ask some random question about derivatives and integrals. This is a tough one. I think we even did this baby bird problem already. We might have done the whole 2012, didn't we? Did we do the 2012 FRQs? I think we kind of worked through those, or parts of them. We didn't quite do all of it. Cool. Back to the story. All right, number 2. I need to move quicker now. I hope number 2 went well for you. I feel like we spent a lot of time on that. You had a calculator for number 2, part A. Acceleration at 3. Did you take the derivative in the calculator, plug in 3? Yes? 1 point. 1 point for that one. Part B. Find the position of the particle at T equals 3. Okay. I actually take that back. I think some of you struggled with this part based on some of your reactions after the test. You're like, hey, I tried to take the antiderivative. My calculator spit it right back at me. I didn't know where to go from there. How many of you had that issue? Okay. It's okay. There's a second method. Remember the worksheet 5? There was the antiderivative, solve for C, plug it back in, and then plug in 3. Or the dirty rule. Remember that? Yes? No? Maybe? Give me a calculus expression to set up 2b. If v of t is 10 sine of 0.4 t squared over t squared minus t plus 3, they're asking you to find s of 3. Well, best case scenario, ready? All eyes up here. Best case scenario, I take the antiderivative of that. I get s of t. It has a plus c in it. I plug in 0, -5. They used x. They used x for the position. X of 3, which is confusing because x is the dependent variable now. Did that trip you up? What's the initial condition they gave us? Did I say independent variable? I said dependent variable, didn't I? Did I say x is now the dependent variable? Okay, good. 0, -5 is a t comma x. Well, I could try to take the antiderivative of that in my calculator, put plus c, plug in 0, -5, solve for c, plug it back in, and then plug in 3 to that function. Do you agree? That's a possible method. Not going to work. Option 2, use an integral notation setup. We got to control the lower bound. You've ever done this? Well, the antiderivative of this thing, dt, well, if I took the antiderivative of this thing, it'd give me the x function. What other things do I need to adjust for? The initial position, good, and about the bounds, right? Well, my position at 3, what 2 things do I need to know my position at 3? What have you been waiting for? You ready? Where did you start? And how far were you displaced? Let's use that expression. I started here. Where did I start? Where did I start? Huh? -5 plus, isn't the integral of velocity or displacement? Isn't this how far I've been displaced? What interval do I want to find the displacement on? 0 to 3. Isn't that going to tell me where I am at 3? Where did I start and how far did I get displaced from 0 to 3? Does that make sense? Can you plug that in your calculator? Yes, you'll get an answer. Bless you. Does that make sense? That's method 2. Method 2 in that worksheet we did. All right. Questions on C? How about D? I just set the velocities equal to each other. Wendy?
I just couldn't find on C the absolute value bars on my calculator.
Gotcha. Yeah, it's in the calculator window or the graphing window. Graphing window.
No, calculator.
Okay, it's the same in both. Sorry, it's this template button right here. And mine are up here to the right. Yours might be in a different location. All right, we got to keep moving. Number 3. Did you guys notice seeing a couple of these as I was scrolling through those past tests? Did you notice seeing a couple of these? This is another really common one on there. All right. Now, always orient yourself with what graph am I looking at? I'm looking at the graph of G, and then I'll be asked about the graph of F in a little bit. All right. Part A. Were you guys okay with part A? 25 halves? Questions on A? All right. B. Integral 1 to 6 of g of x. And you do that by hand. I think there's at least needs to be a conversation about this right here. The integral or antiderivative from 3 to 6 of 2 times x minus 4 squared dx. How many of you felt the need to FOIL that out and distribute the 2 because you weren't too sure about using the power rule on that? How many of you did that? By the way, you're not allowed to use a calculator in this part. So how many of you did that? Okay, how many of you added 1 to the exponent and divided by the new exponent and just got 2/3 times x minus 4 cubed? Got this as your antiderivative. How many did that? Why is that allowed here? Why am I allowed to raise a binomial to power and use the power rule? Tom?
Is it because if you use chain rule, the derivative of the inside would be 1?
Yes, very good. Yeah, to work backwards, you could try this with the chain rule. And that times the derivative of the inside is just a 1. There's no adjustment necessary. Remember the u substitution we did? There was a chain rule portion to it, so we couldn't have just done the antiderivative with the power rule. Very good. It's that same reason. Questions on part B? All right, part C. Is the graph of f on what intervals, if any, is the graph of f both increasing and concave up? Questions on that one? And you had to give a reason. Make sure you're counting points for that. Because f prime and g are both positive. Wendy?
Do you have to say like it's increasing and concave up, or just one or the other?
The question said, on what intervals is the graph of f both increasing and concave up? So you could have just said on. I think you could have just given the intervals there, because they've already prompted you with that in the question. You have to give the reason where f prime and g are both positive, and f prime equals g is increasing on those intervals. Good? All right, part D. Find the x-coordinates of each point of inflection. So you have to take the second derivative, which is f prime. Changes from decreasing to increasing at x equals 4. I'm wondering, did anyone use a f double prime, which is g prime positive negative argument? You did? That's pretty fine too. Yeah. Did you say f double prime, which equals g prime, changes from negative to positive at 4?
Positive to negative, but
let me double check that. I need to look at the, well, hold on, here's the graph. F double prime, which equals g prime 4. You put what?
It was negative.
Negative positive, yeah. How are we doing? All right, number 4. All right. Might just need to go to what questions do you guys have? Like, do you want to ask me about instead of going over all these? This is one we've seen multiple times already, just scrolling through past years. H prime of 6. 6 wasn't in the table. You had a 5, you had a 7. You do the average value. Done.
For part B,
Yeah.
like I just used like the mean value theorem, and I didn't do the H5 minus H3 over 5 minus 3. I just used the mean value theorem just to like kind of just like explain how 2 has to be. Like, do I have to use the H5?
Yeah, they give a point for that. And they don't ask my opinion. I think they should give you more prompting to do that because the wording says explain why there must be at least one time where H prime equals 2. It doesn't say to calculate through calculation show that H prime equals 2. I would agree with you. I don't know that I would have read that from it. But now that you know, hey, this is a huge theme throughout the test. You have to show the setup. Like, you have to show to the setup, conclusion, and then use the words mean value theorem, or even better, MVT. They'll accept MVT as an abbreviation for mean value theorem. Sometimes, they already said it in part A. They'll say explain using correct units, okay, which they already did in part A. Cool.
When you have these types of problems, it says H prime T equals 2. Are you just supposed to go through and find where the slope is 2? Like, how are you supposed to know that it was 5 and 3 other than just essing each one?
Yeah. Yeah. So you would have had to gone through there. You're saying other than just guess and check?
Yeah.
From experience, what I've noticed them doing, I haven't seen this one that often, where it's because it was the T, it was 2, 3, 5, 7, 10. I'm not promising this. 9 times out of 10, the mean value theorem argument will come from the whole interval having an average slope of something. Therefore, there must be a time on the interval from 2 to 10 where the instantaneous rate of change is that. Okay. But for this one, yeah, you kind of had to, I think you had to kind of guess and check on that one. Don?
So like on most problems, like, so I explained where I said like the average slope from 2 to 3 was 0.5, and then from 7 to 10 was above 2. And then I explained how, like, because those are greater than and less than, that at some point there has to be 2. On most questions, would that be given credit?
Boy.
Or should I be more specific trying to find it?
Yeah. I kind of like that argument though. You'd have to know. Did they say anything about H being twice differentiable? So that's okay. I don't know if they give credit for it. They don't tell me if they give credit for that argument. But since H is twice differentiable, you're using the argument that H prime changes from 2 to 2.5?
Yeah.
And therefore, there must be a time where H prime equals 2?
Yeah. That's how I explained it.
That's a calculus based argument. I would hope they would accept that. All right, part C. Average height of the tree. Did you guys recognize average height of the tree as the average value of the function? Remember doing that? 1 over b minus a times the integral from a to b of f of x dx. That's the average value of a function formula. If you change f to h, now it's the average height of the tree function. And you had to use a trapezoidal sum for that. All right. I'll be honest, a question like letter D, I'm not going to spend time on it right now. That might be one if you want to ask me individually, I can go over it with you. There's some of these questions you have to be honest with yourself and say, like, I'm not saying this is an impossible one. I'm just saying, if your goal is to get over half the points on these, there's some of these parts that are just not going to be realistic. And you have to be okay with that. All right. And I'm not saying give up. I'm just saying with our time right now and what's left, like our time would be better spent focusing on the ones you're going to see with repetition. All right. So on to number 5. Man, how many average rate of change problems have we seen on this test already, right? I mean, big idea. It's a big idea. All right, we're going to run out of time here. I do want to talk about number 6 for sure. I'd like for you guys to take another look at number 6. Number 6 was a separable differential equation. You had to get the y's with the dy's, the x's with the dx's, take the antiderivative of both sides, solve for c, then solve for y. All right. This is one I warned you guys about being a lot of points focused in one part. Look at that. 5 points on letter C. And remember how we walked through this together? Did you separate the variables? Did you take the antiderivatives? Did you remember C? Did you solve for C? And did you solve for Y? When we did this, it was in section 6.4. When we did this, we talked about those are the steps to solving this type of problem. You have to recognize it. You're going to see the word initial condition, separable differential equations, and so forth. So things you need to do tonight, refine what you need to ask about 5 and 6 on this, and then also start your weekly agenda. There's a lot to do. Make sure you're getting started today. Have a great day.